Have you ever just looked around and wondered what everything is really made of? I mean, the mountains, the chair you're sitting on, even the air you're breathing, it all boils down to this hidden world of super tiny particles. And today, we're going to uncover it together.
Okay, picture this. You're at a riverbank. You can feel the cool water flowing. You see all these smooth stones. It's pretty simple, right? You can grab a stone, stack it on another one, maybe build a little tower. But what happens if you try to do that with the water? Yeah, not so easy. And right there, in that simple difference, lies a huge secret about how our world works.
So that really gets us to the big question for today, doesn't it? Why can you pile up stones, but you can't pile up water? Why does one stack and the other just flow away? The answer, it turns out, is all about the fundamental building blocks of, well, everything.
All right, so here's our game plan. First, we'll go from mountains to grains. Then we'll hunt for the smallest possible piece of something. After that, we'll dive into the invisible worlds and hidden rules that govern them. And finally, we'll put it all together to understand the three states of matter. Let's get into it.
Okay, part one, from mountains to grains. We're going to trace the journey from the absolutely massive to the super tiny. So think about it. For millions and millions of years, you've got wind and water just hammering away at huge mountains. Rivers are like these giant natural rock tumblers, right? They're constantly grinding big rocks against each other, turning them into smaller pebbles, then into tiny grains of sand, and eventually into superfine clay. It's this amazing, endless process of big stuff getting broken down into smaller and smaller stuff.
So this whole process is a perfect example of how big things are just made up of smaller things. But is that it? Is a grain of sand as small as it gets? Is that the end of the road? Or can we go even smaller? And that question leads us right into our next section, the smallest possible piece. We're going on a hunt for the fundamental building blocks.
All right, let's do a little thought experiment. Imagine you've got a piece of chalk. First, you snap it in half. Easy. Then, you take those pieces and grind them up into a really fine powder. But here's the thing, and this is super important. If you looked at one of those tiny, tiny specks of powder, guess what? It's still chalk. You made it smaller, but you haven't changed what it actually is.
Okay, so let's imagine you have a superpower, and you can just keep grinding that chalk down smaller and smaller and smaller. Eventually, you're going to hit a wall. You'll get to a single, tiny piece that you just can't break down anymore without it stopping being chalk. That final fundamental unit is what we call a constituent particle. It's the absolute basic building block.
And get this idea is ancient. We're talking thousands of years ago, an Indian philosopher named Acharya Kanad was already talking about this. He said everything is made of these tiny, indivisible particles that he called Parmanu. So yeah, people have been thinking about this stuff for a very, very long time.
All right, so we've established that everything's made of these tiny particles, but what are they up to? What are the rules of their world? Let's dive into this invisible world and see if we can uncover their secrets.
Think about something you've probably done 100 times, dissolving sugar in water. You stir it in, it disappears. But what is really happening on a microscopic level?
You see it, right? The little white crystals swirl around and then, poof, they're gone. The water's totally clear again. It looks like the sugar just vanished into thin air. But we know better, don't we?
Because if you take a sip, it's sweet, so the sugar is definitely still in there. This is a huge clue. It tells us the sugar didn't just disappear. It broke down into its individual particles. Particles so incredibly small that we just can't see them anymore. So where did they go? This is the cool part. They squeezed into the tiny empty spaces between the water particles. Think about that for a second. That glass of water that looks like one solid thing, it's actually filled with these microscopic gaps. It's not as solid as it looks.
So this little sugar experiment just taught us two really important rules about particles. Rule number one, they are ridiculously small, totally invisible. And rule number two, there has to be some kind of force holding them together, right? An attraction that stops them from just floating away on their own.
Okay, we've got all the clues now. We know about tiny particles, the space between them, and the forces that hold them together. Now we can put it all together and finally solve that mystery from the beginning. It's time to talk about the three states of matter.
You know the basics, right? A solid holds its shape, a liquid takes the shape of its container, and a gas, well, a gas just goes everywhere, filling up whatever space it can. The why behind all of this? It's all about how their tiny particles are acting.
Let's go back to those stones.
In a solid, the particles are jammed together, super tight. The forces pulling them together are incredibly strong, so they're locked into this rigid, organized pattern. They can't really go anywhere. All they can do is just sort of vibrate in place. And that's why a solid is solid. It gives it that definite shape and volume.
Okay, now think about water. In a liquid, the particles are still pretty close, but those forces holding them together are a bit weaker. It gives them just enough wiggle room to break out of that rigid structure and slide past each other. That's the secret to flowing. It's why a liquid can take the shape of any glass you pour it into, but it still takes up the same amount of space.
And then you've got gases. This is where things get wild. The particles are super far apart from each other. The forces of attraction? Almost nothing. They're just zipping around randomly in every direction, completely free. And that's why a gas like the smoke from an incense stick will just expand and expand to fill every last corner of a room.
You know, because both liquids and gases have this ability to flow, we actually have a word for them both: fluids. And that ability to flow is really the key thing that makes them different from solids. So, let's circle all the way back to the beginning. The reason you can pile up rocks but not water? It's just because the particles in the rock are locked down tight, and the particles in the water are free to slide and glide all over the place. That's it. It's so simple, but it's also incredibly profound. Our entire physical world, it's all built on these basic rules.
And I'll leave you with this one last thought to chew on. If everything, your hand, the desk you're sitting at, if it's all just a bunch of tiny particles vibrating in mostly empty space, what does it even mean to touch something? What are you actually feeling? Kind of makes you think, doesn't it?